Now we know the typical structure of an atom. A nucleus at the center with protons and neutrons surrounded by electrons. For instance, let us have a look at the structure of an oxygen atom. Does it look somewhat like this? Yes. But can you tell me why we have 2 electrons in the first shell and 6 in the second? We could have just divided them equally and put 4 electrons in each shell, right? No, that's not possible. Electrons cannot be present randomly in any shell. Allocating electrons to orbitals have specific rules. Let's understand the rules related to electron distribution in the respective shells. Wait, do we have a formula to calculate the maximum number of electrons in each shell? Yes, of course. The simple formula 2 times n to the power 2 gives us the maximum number of electrons that can possibly be accommodated in one shell. It's 2 times n to the power 2, where n indicates the shell number. Let's calculate the electron number in the shells of an atom to understand better. The first shell that we have is the K shell, right? That means the shell number is 1. So substituting the values we get, 2 times 1 raised to 2. That is 2 times 1. Thus, the maximum number of electrons in the first shell, that is the K shell, is 2. Similarly, if we wish to calculate it for the L shell, that is the shell number 2, we get 2 times 2 raised to 2. That is 2 times 4, which is 8. So what does this number 8 tell us? Yes, it tells us that a maximum of 8 electrons can be present in the second shell. Now, can you tell me the maximum number of electrons the third shell can hold? Let's find out. 2 times 3 raised to 2. That is 2 into 9, which gives us 18. And what will be the maximum number of electrons in the fourth, that is the N shell? Yes, it will be 2 times 4 to the power 2. That equals 2 times 16, which gives us 32. So we know the maximum number of electrons a shell can have. Now comes the interesting part. Assume we have an atom which has 20 protons and 20 neutrons in the nucleus, surrounded by 20 electrons. How will we arrange these electrons in the orbitals? I want you to give it a try. We will see the solution in the next video.